Hey, welcome back. Episode 4 edition with DR. All ready to go with our first live guest today. Very excited about that. But before we get started, Hitesh Kshatriya is not able to be with us today. So we have Danielle Alfer, our producer, standing in his spot. She'll be bringing us up to speed on all the important information around Dishin with DR in just a few minutes. Really super excited for the first in person. It's great to have people back or in studio for the first time, and looking forward to hearing a little bit more from our guests. But before we do that, if you haven't already, check out episodes 1, 2, and 3. They're still available on YouTube for your viewing pleasure. And Danielle, why don't you tell us a little bit more about where they can be found, as well as sponsorship information?
Hey, everybody. Thanks for tuning in. To be a guest on our show, you can simply send us an email to podcast@dishinwithdr.com. To watch our episodes, you can always find us on YouTube and LinkedIn. And while you're at it, please like this episode and subscribe to our channel. Episodes are also available at www.dishinwithdr.com. And we can have those episodes listened to by tuning into Apple Podcast, Google Podcast, Spotify, Breaker, Pocket Cast, and Radio Public. And thanks to our sponsors, we will continue to upload episodes on a regular basis. This episode is sponsored by RK Squared. Flexible, transparent, on time, and under budget. A fresh new approach to in-building. RK Squared, redefining in-building. Find us at rksquared.net. Back to you, Dennis.
Hey, thanks a lot, Danielle. It's a lot of information, a lot of good information. Thank you for all of that. So I think we're ready to start this conversation. Today, special guest, first in-person guest, as I mentioned, Luke Getto from VoltServer. Luke, welcome.
Thank you, Dennis. It's great to be here. Great to be here in person. Quite refreshing to see people face to face after the year plus of being behind a Zoom screen.
Yeah, unfortunately, my face is the first one you're getting to see, but other than that, we're in pretty good shape. Yeah, Luke and I just, speaking of being together and getting to do things, we actually got to sit down and have a little bit of a little lunch before today's episode. Looking forward to sharing some pictures of that, and nothing like a good Jersey thin style pizza to start off a podcast.
Yeah, very good. It's not hard to find good pizza here in Jersey, but this was excellent. So
yeah,
thank you.
I tell everybody, pizza and hot dogs. We're good at certain things here. So
and bagels.
There you go. So we'll go ahead and get started. Today, Luke comes to us with 15 years of experience in engineering, project management, upper management, senior management in the wireless space. He started his professional career working with GPS satellites. So Luke, I'm not sure if this is true or if I'm going to say this in a true fashion, but what I understand is some of your designs are orbiting Earth and may help my Uber driver find me on a Friday night after I've had a couple of adult beverages.
Yeah, it's actually funny enough, something I designed almost 10, 15 years ago, was just launched a couple years ago, and it's a new GPS constellation, so I had a hand in that, and very proud of it.
Excellent. Then I heard, if I understand correctly, you moved over to terrestrial communications and CommScope for a little bit, Microlab.
Mm-hmm. Yeah, so I spent a couple years at CommScope, Andrew, working in their MCPA division, the base station amplifiers. And after that, I was at Microlab for about 7 years. They're a well-known RF passive component provider. I held several roles there, including engineering, product management, project management, and really had a good experience there. And then, as you mentioned, just recently, I kind of moved over to VoltServer.
Excellent. So we'll learn a lot more about VoltServer and Luke's new role here in just a few minutes. But before we do that, our guests continue to impress. I understand also you have one patent and one patent pending?
That's correct. Yes, I have one patent that was granted on a GPS repeater system, and one patent pending on something involved with our smart passives that we did at Microlab.
Oh, very cool. Excellent. Well, like I said, impressive guests here on Dishin with DR. Let's see who may be able to, one up this current guest with their resume. So now you're the director of product management
Correct.
as well as many other roles I understand at VoltServer.
Yes, it's a growing company, and we all kind of contribute wherever we can, and so everyone kind of does a lot of everything. Handle a little bit of marketing, product management, a little bit of business development, and it's been great to wear all those hats and feel good about it.
Yeah, I think I said at lunch, it's a jack of all trade is what I would refer that as, somebody that's got their hand in just about everything and helping the company grow. Well, that's terrific. Luke, again, we're glad to have you. And a little bit about VoltServer, digital electricity. I think that's your patented kind of term or trademark term. You want to tell us a little bit about, VoltServer overall, and then we can kind of get into the marketplace.
Sure. So VoltServer is a venture-backed company. We're the inventors of digital electricity, which is a patented technology that sends packets of energy over copper wires so you can deliver significant amounts of power over significant distances. So where the technology really fits is it kind of bridges the gap between AC power and low voltage DC or power over Ethernet. So on the power over Ethernet side, you got a little bit of power. It can go a certain amount of distance. It's very safe. You can grab those wires and you'll be okay. Whereas you stick a fork in the outlet in your wall, you're not going to be so much. Got to worry about that. But the AC outlets can deliver significant amount of power over significant distance. We fit in that sweet spot in between. The digital electricity actually allows us to classify as a low power system, so it can be deployed like PoE, like Class 2 power. If you touch it, you're going to get a very, very minor pinprick of a feeling, not dangerous, but we can deliver 20 times the amount of power as PoE up to 20 times the distance.
Very cool. Very cool. Well, it sounds like a terrific product, terrific patent, terrific solution for many problems. And we'll start to explore some of those problems now. All right, great. So, well, Luke, let's talk a little bit about what some of the challenges are at the edge of a fiber network.
Mm-hmm. So fiber to the antenna, something the industry has been talking about for a long time. Sounds great. Fiber delivers a ton of capacity to the edge of the network, but those devices at the edge still need power. It's, you can't get power through your fiber, not yet. So, you have a ton of capacity going out to the edge, but you need to plug in those radios, whether it's 4G, 5G, Wi-Fi, you still need a plug at the end. And it just so happens, we call it Bob's Law in the office, is one of our coworkers. The optimal place to put your RF radio is not the optimal place where an outlet is located. These are typically located on the ceiling. You don't see a lot of outlets on the ceiling. So, to plug these in, make sure they have resilient power, that's where we come in. We allow you to kind of route power to where and when it's needed in whatever format it's needed, DC, AC, low voltage DC, high voltage DC, and power those remote devices with an inexpensive multi-conductor cable that can be run by your IT staff, your electrical integrators, your low voltage technicians, rather than having to run dedicated AC conduit out to all these locations.
I assume then too, I'm just thinking about like my experience with what I would consider a traditional active passive kind of solution where you maybe have a 20 watt or a 5 watt remote in an IDF someplace, and then you're running passive, which doesn't require fiber to the antenna, doesn't require power to the antenna. Now you have these antennas out there, you can power the antenna, and can you also then kind of back up that antenna from a power perspective, which even if you have an AC outlet somewhere close enough, they're not always backed up. Can you give the guarantee of redundant power?
Yes. So that's really important when you're deploying a commercial wireless network. These things, they can't go down. People depend on them not just for their videos and their chat, but also, to call emergency services, to call their friends and family when they need to. So these things need to be up all the time. And as you mentioned, most plugs, if you plugged into the wall, if the power goes out, that outlet's going to go out. Also, you don't want to have your critical infrastructure plugged into the wall where some guy is going to unplug it and plug in a space heater in the middle of winter to warm up his feet, in a cold office. So what we do is we power all of these things from a central location. We, the DAS head end and all these things, we bring all of that copper or hybrid fiber cables back to the head end, and we power them from there. And from there, we can use either a large uninterruptible power supply or UPS or a battery plant. And that battery plant can then be powered off the AC mains. The AC mains provide the primary power, the batteries are then the backup power, and everything connected to the digital electricity platform is then backed up for as long as those batteries will provide power.
So not only can I flip a switch and make it work, I can flip that switch and know it's going to continue to work. That's what I heard as a sales guy.
Yeah.
Sounds like a pretty easy product to sell. So I'm thinking, in my mind, what you're talking and the term PoE sound, again, not technical, in my mind, sound like they're similar. Can you tell us a little bit about how they differ?
Sure. The industry technology industry fairly familiar with PoE right now, power over Ethernet. So basically, same problem. You plug in these devices, they need data, but they also need power. So the problem was solved by PoE, and rather than running a power cable and a data cable to a device, they combined them into a single cable, and then the PoE switch provides the power and the data, right? But PoE is limited. It's got a limitation of about 300 feet and 100 watts, to make the math easy. So 300 feet, 100 watts, very limited in what you can power. Yes, certain Wi-Fi access points, lighting, building controls, things like that. But you can't go very far away from that, central location of where that switch is. It's typically located in an IT closet, MDF, IDF, whatever. And it's 100 watts. You can't do 101. You can't do 100.1. It's 100 watts. And, certain things, they just consume a lot of power. You talk about 4G, 5G radios doing hundreds of megahertz of bandwidth. Those are not limited to 100 watts. Those can be 500, 600, 1,000 watts. So that's where we come in, is to provide that extra amount of power. And then we can go up to 2 kilometers to provide that power. So, now in your building, you don't have to be as close to your IT closets. You don't have to be as close to those switches. You can be, pretty far away from the head end in terms of vertical distance, horizontal distance. You think about office towers or warehouses, stadiums, you got a lot of space there to cover, right? So that's where we play in our sweet spot with digital electricity.
Cool. And I think, we talked over lunch a little bit about, my mind and Hitesh mostly goes to wireless, cellular, Wi-Fi, private LTE, and we look at your product from that perspective. But over lunch today, we were talking a little bit more about like other applications outside of what our industry would normally do, things like maybe digital signage and some stuff like that, some hotel applications with in-room electronics. So am I correct, right? Your product expands well beyond just, our focus is often the low voltage cable companies, providers, and their scope is much larger than just DAS.
Mm-hmm.
So for them, this product actually could solve other solutions, correct?
Yeah. We have 2 other verticals that we address. The first being what we call the intelligent building. I know a very nebulous term, can have lots of definitions and things like that. But one example is the Westfield Public Schools here in New Jersey, not too far away from where we sit right now. We worked with them to back up everything. They wanted to bring all of their equipment, they wanted to power it off of PoE. That's great, but the problem was these schools, they're not very new buildings. They're not building a lot of new schools. These schools are very old. They got problems with electrical distribution, potentially asbestos, all those kind of things. And, drilling new holes and all that kind of stuff can be a hassle. So to bring an electrician in and run new AC for all these new applications, Wi-Fi, lighting, the PA system even, things like that, very expensive. They wanted to go to PoE so they could be kind of the master of their own destiny. They can have their IT staff go move that access point. They can have their IT staff, hook up a building access control. But they had to bring it all back to an IT closet in a very old building, not air conditioned. It was getting very, very warm with all those switches being located in it. How do you back up those critical applications? You can't have your building access controls in a school go down. It's a safety critical application. The problem is in those IT closets, what's your option? Well, you could power them off UPS. But UPS, for every 10 degrees they go over ambient temperature, you reduce their life by half. So you're going to be replacing them often. You're going to have to monitor all these UPS located across the entire school district, not just to mention a single building. So what we did is we powered all those switches off of our digital electricity, and now we bring them all back to the head end in each school, and they have a really, really big UPS that powers everything. We got nothing against UPS. We just like really big honking ones. And that's all in a climate-controlled environment. So now that all those applications are all backed up power off of one location, and they can go in there and make sure that that thing's running. And that'll give them a temporary backup, and then they have generators to go further than that if in case they need be.
So if I understand high level, but you're really talking about a big benefit to centralizing your distribution point, your distribution network. You're bringing it all into one place, and because of that, it gives you a lot more value, flexibility, benefit to in this case, the school district.
Mm-hmm. It's the same kind of thing that you've seen in many industries. You go from a decentralized model, having all these UPS spread out all over the place, to a centralized model. Bring that all back to one place, one monitoring point, one battery, one neck to choke, as they like to say.
Got it. And then is there in the power realm, is there DC, AC, PoE, Class 2? Are there different benefits or values to any of those, or is there a better one type of power for your solution?
I think it's all. It really depends. Some in the carrier space, they like to have their DC battery plant, so they like to power everything off of DC. It's basically an AC into the battery plant and DC everywhere. But DC is not well recognized everywhere. Pretty much nobody has a DC outlet in their home anywhere. Yes, all your devices in the end run off of DC, but everyone knows what an AC electrical outlet looks like. So we need to be flexible. We need to be able to plug into the wall and get power off of the regular AC mains, things like that. So we have a variety of equipment, both at the head end and at the receiver end. We call them our transmitter, which takes in your typical analog power, AC or DC, transmits power over digital electricity out to our receiver, and then we can convert that to either DC or AC, feeding whether it's PoE switch, Class 2 hub, a radio, or what have you.
So you mentioned transporting that power out to an end point, a device, whatever it may be. You mentioned earlier 2 kilometers. So first of all, for us inch and mile people, can you?
It's about 6,500 feet.
Okay, so there you go. So 6,500 feet, 2 kilometers. That's obviously much more than you'll need in a building. But how does this work in a campus environment, like in maybe a university or something that's spread out where there's multiple buildings? Can you talk a little bit about the value it would bring there?
Mm-hmm. Yeah, so that's kind of the model there is like, rather than having each building perhaps have its own, power distribution infrastructure, you could centralize all of that into a single area, and you could go from there. You could power things that are indoor, outdoor. You could share the equipment at the transmitter head end between those. So, a campus environment, those are areas we play well in. Also things like stadiums, right? Very large airports, they have, multiple terminals, things like that. So we can power, whether it's the radios or things like that, going further and deeper into these buildings with that, low voltage application.
Much like the wireless industry, where the carriers are looking to make their radio equipment smaller, take up less space in a head-end room, connectivity to their core networks being, through fiber or whatever it may be, and less equipment. Real estate's at a premium in a lot of these places, difficult to get. Sounds like on the digital electricity side, you're solving some of those problems on the other side, which is how do I power these things? I can take up less space, use less real estate, extend this further. It's almost a mirror image of what we're going through on the network side. Am I understanding that correctly?
Mm-hmm. Yeah, so it costs money to basically rent space in these IDFs from the building owners, things like that. So the carriers or the neutral host companies, they want to come in and put as little equipment as possible, right? So we can, take our receivers and put them right next to the radios. They can be up in the ceiling or on the pole or whatever it may be, to get the best coverage, the best location for those radios. And then rather than having a power plant out in multiple IDFs, you bring that back to the central MDF, the head end, where you've got many of these racks already, right? So you're going to significantly reduce the footprint of these installations.
That's excellent. I mean, real estate, in many of these deals, not only is real estate expensive, oftentimes, especially in some of these older buildings, it's frankly just not available. There's not enough room to put all the electronics, battery backup units, all of this stuff in one room. So, beyond the rent portion of it, just the general flexibility as far as what you need is a tremendous asset.
Mm-hmm. And, just as I mentioned before, you talk about those rooms with all these expensive, hot electronics, right? Well, they may not be conditioned, right? So now you got the more electronics you're going to put in there, the warmer they're going to get, the worse these electronics are going to perform. So we save on the footprint, the real estate cost there, and as well as just, not generating that extra heat to impact the lifespan of anything else that's in these crowded closets that you mentioned.
That's excellent. We talked earlier about fiber to the edge. A couple episodes ago, we had Ken Senfeld from Solid on talking about Solid's new fiber to the edge platform. We've talked about today. We talked a little bit about other things like digital signage or whatever, many other smart city or intelligent city applications. If you look at an entire building, or if you look at it from a wireless perspective, you have Wi-Fi, cellular, possibly public safety, CBRS, or private LTE. Maybe even you have small cells or possibly even something on the roof or whatever. Are you able to look at holistically all of these solutions and, like we do in the wireless industry in IBWave, kind of make a plan for how to support all of that?
Yes. So something we offer to our customers is a free design service. Digital Electricity, does not have a platform, simulation platform yet. So, we know that this is a new technology. People may be hesitant to adopt it, even though we're, well proven in hundreds of high profile venues. May be difficult to understand. How do we get it out there? So our team of solution engineers will work with you. People send us designs, and they say, look, how do I get power to these devices? And then we'll look at it from a holistic standpoint. We'll say, look, yes, you can power A, B, and C with this, but if you were also to power D, E, and F, you save on those economies of scale, right? So now, rather than running AC that's going to power a certain set of equipment and digital electricity, maybe just combine it all down to digital electricity, and you don't need to run those conduits, hire those expensive journeyman electrician, things like that.
Got it. Well, listen, I mean, I learned a lot today. I mean, to me, from a practical application perspective, it makes complete sense. I can see the value. I understand the kind of the position you hold in the market, and I see a lot of opportunity for this to complement the fiber to the edge wave that we're going through right now, and not just that wave, but as we look at some of these newer technology or bands or frequencies like millimeter wave, which likely going to be more small cell oriented and things like that, or even as carriers deploy new bands, maybe they want a spot cover for 5G. I mean, I think there's a tremendous opportunity here for digital electricity.
Yeah, we hope so. I mean, like kind of was saying, is that fiber to the edge, we're big advocates of it, but you're going to need to power those devices. They're not passive components. And to get that power all the way out to where you need it, when you need it. Another benefit of this is the time to deploy. These is much faster. We looked at one building where it would have taken a couple of weeks to deploy, conventional electricity to bring it up. We did it overnight. We dramatically, 90% reduction in time to deploy this thing. You pull it up your existing fiber risers. You don't need a dedicated riser. The flexibility of the platform. You can add, move, change with your IT staff, with low voltage technicians. You don't need to call an electrician to run a new circuit. So,
Well, the comment you made about pulling up your existing riser and not needing new conduit, I'm not an installer, but to me, I've heard on projects where that could be a make or break type of, if you need to put new conduit in, or if you need dedicated space conduit, sometimes that could drive the price of the project to the point where it's no longer feasible.
right. Yeah. I mean, it's not cheap. I mean, to run new core bore, you got to do it probably at night when the tenants aren't there. If you can do it at all, some of these buildings, as I mentioned before, they're not new. You could be running into hazardous material problems of asbestos and things like that. So being able to use your existing infrastructure, but being able to deliver more power out to wherever you need it, as well as back up that power from central location. That's really where we think our value is, and we've seen it over and over again. In these wireless deployments, intelligent buildings, which we've done a lot of. And actually, I forgot to mention one other area that we've been in is indoor agriculture. So we've kind of gotten into this, and it's been somewhere we explored because these indoor farms, they need a lot of power, and we can deliver that power very efficiently.
So Luke, you're a Jersey guy. I'm a Jersey guy. You're starting to talk about indoor farms. Does this have anything to do with Governor Murphy's new legalization of a certain type of plant?
Yes, it does. So we've done cannabis farms, right? So we've done a few trials. I wouldn't even call them trials. These are real deployments with cannabis farms, and we've basically pulled the driver out of the LED that's the plants are growing from, and we're able to deliver more light at a lower cost than anybody else in the industry. That's very valuable when you talk about a plant that goes for thousands of dollars per pound. However, we've also worked with customers growing tomatoes, and microgreens. So we have a large 1 megawatt installation where we grew, those type of, things you'll find not in a controlled substance manner. And we've been pretty successful there too. So, but yeah, this is a budding industry, pun intended. And, so we'll see how it goes, but it's been pretty interesting.
Awesome. Well, not only diversity in what you can support, but in the industries that you support it in the applications you support. I mean, that sounds great. Well, Luke, how about to give you an opportunity here to anything else we need to know about VoltServer? Anything else that you'd like to talk about?
I think we've covered pretty much everything. I'm really, really happy to be here again in person, on your podcast, and great to meet you, in person here. And, it's kind of like coming out of a dark cave, all of a sudden, everything's just been opened up and you kind of got that, got to get used to it again. But it feels good. It feels good to be out here.
Well, excellent. Well, Danielle, before I have you wrap up, I know you're doubling down on your cannabis stocks right now after all this insider information. So hopefully you can make some money there. But Danielle, I'd like for you to maybe wrap us up with some comments and closing remarks.
Great chat, very interesting. I learned a lot, and I definitely see this being deployed quite a bit in the future, especially in those school districts you were talking about.
Beyond your dogs speaking in the background there, do you want to give us some sponsor information and once again, just quick where they can find us?
Yes. So to be a guest on the show, email us at podcast@dishinwithdr.com. To watch our episodes, you can find us on YouTube and LinkedIn. And please like this episode and subscribe to our channel. That would be great. Episodes will also be available on www.dishinwithdr.com. And then you can find us on the major podcast platforms such as Apple Podcasts and Google Podcasts, among others. And thanks to our sponsors, we will be uploading episodes on a regular basis. This particular episode was sponsored by RK Squared. Thank you for that. Flexible, transparent, on time, and under budget. A fresh new approach to in-building. RK Squared is redefining in-building, and you can find RK Squared at rksquared.net. Thanks so much.
Thanks, Danielle. We I think, Danielle, if I'm not mistaken, we have potentially an episode coming up to talk a little bit about the broadband initiative in New York. Is that next or it's coming up soon, right? Very interesting one.
Yes, coming up very soon, if not next. And we're going to be talking about the hotbed right in the city, right in Harlem.
Excellent. Well, speaking of hot, right before, after Luke and I ate our pizza, before we had a dash here, the waiter was bringing out a couple of tortonis, and they're probably melting back there. We got like a 4-mile ride. So, Luke, I'm going to thank you for being part of this conversation today. We can hustle back and get our ice cream before it melts.
All right. Sounds good.
Thanks, everybody. Tune in
Thank you.
again.